was like, your graph looked like that, and you had to find these two, which were somewhere up there, so you found them like over here. I know, that's annoying. What shall we do? Okay, cool. So with that, we'll get rid of that. And that is all I wanted to discuss today, which means, oh, I should have left that on. We can talk about the test. Dun, dun, dun. So, things you should know for the test. Everything on the last test. What did we study since the last test? That would be chapters 5 and 6. So, what is covered in chapters 5 and 6? Yes, sir.
So I don't know. I think I misplaced the last test. Is there any way you can have like it can have
No.
What is that?
No.
Why is
Because
it?
I don't do that.
Yeah, you don't do that. Can I get a friend?
Yeah, sure.
Can I take pictures?
There's like 13 of them in this
Can I
class.
take pictures of my friend?
I don't care. It's their test. You can do whatever they let you do with their test. Yeah. So, good question. Yeah. Or if you don't have the right answers, remember like the day after the test, I always go over them and like give you the right answer, like spoon feed, here's the right answers. So like I would encourage you to choose, maybe if you weren't like, how do I put this nicely, particularly attentive that day, perhaps you get a friend who was particularly attentive that day and like review their notes of the correct answers. That would be good. Yes?
Have you like taken two like exams?
Yeah, I average every other chapter. Yeah. Because we're like 7 to 8 weeks in if you take out fall break and then like weird days. It's like a chapter a week. That's the goal. Cool? Shall we? We shall. All right, so chapter 6 was all about the octet rule. We talked about diatomic elements, so you should know those. What are the diatomic elements? Missing one. Okay, so those guys exist in pairs, so you should know them. Then we talked about Lewis dot structures. What are the 7 steps, 6 steps to a Lewis dot structure? Okay, step 1, you are going to electron dots. Step 2. Count valence electrons. Step 3.
Some paired atoms in the center.
Those are like robots. Step 4.
Place the remaining around the center atom.
Number 5.
Complete as many single bonds as possible.
6.
Draw double or second bond if needed.
Okay. 8. 7.
7.
Count electrons.
Okay. 7 was recheck.
What's number 3 saying? Most unpaired
Center. Okay. Yes.
Should we know like the steps themselves or how to apply them?
How to apply them? I'm not going to be like, what's step 5? That would be terrible.
No.
No, I'm not going to do that. No, just know how to apply them. Okay, if you're still struggling with Lewis dot structures, and like not the weird ones, but like the normal ones that like work out nicely.
Those ones are fun.
The other ones that are like, oh, this is impossible, have fun. So, good lists of them that you would use I mean, basically all the section reviews we did. So if you do section 6B review, that one's good. Hopefully that's in your notes as well. So you could like look at the formulas, redraw them, and then compare and make sure you got it. There's also those problems 13, 14, 15 on chapter 6 section review, which you could also go through again and just make sure you have that down. This is not just for now, it's going to like be a big deal as we continue chapter 7, which is all of the geometries anyways. So very important. Question? You raised your hand. You had one. Did I answer it?
I couldn't read handwriting at first and then finally made it.
Oh, you got it? Yeah, I know. You guys are at like the prime time for bad handwriting. It's like first thing in the morning, the seniors, man, they get like beautiful handwriting. And then it like wavers. And then after lunch, it's like a refresh and then it's good. And then you guys get the worst. Sorry, that happens. All right, cool. So that is Lewis dot structures. Then we talked about polyatomic ions, which are the ones where they have a charge to them. So adding those extra electrons randomly. It's not as random as you think. So let's try one more in review. Do I have one for review? Yeah, I have one for review. Of course I have one for review. Let's do I have no review. That's it. It's over. There's nothing to review. We can't learn anything anymore. So let's do ClO3 minus. Okay? So first step, we're going to draw all the atoms. Cl has 7. Oxygen, 6. Okay, now we are going to connect the ones that are, or we're going to complete the single bonds. So obviously here we have some issues, right? Like this guy can maybe bond with one of these. And then this guy is a happy camper. And this guy's a happy camper. Okay? So if there's 2 electrons just hanging out there, likely they will form that bond.
Oh, okay. And so it doesn't matter if that one's in the everything. Okay.
Yeah, because your goal is to get 8. Okay, from there, what are you going to do? Well, oxygen has 8 electrons now. Chlorine has 8 electrons. This oxygen has 8. This one has 7. So where does this extra electron go? Remember, if you have a minus, you're adding an electron. It goes to the one with 7. So that now has 8. Everything fulfills the octet rule. We're happy campers. Yeah.
Are those two supposed to have 2 lines going down? No, the ones that go left from CL and the ones that go down, is that supposed to be 2 lines?
No, just 1.
But there are 2 dots.
There's 2 electrons per bond. So this bond is 2 electrons. Good question. So each single bond is 2 electrons, each double bond 4, triple 6. Okay. Yes? No?
For some reason how many does chlorine have? Doesn't have like 7.
Chlorine has 7. So like HCl, hydrochloric acid, chlorine has
Like,
7.
does it, like, has, so chlorine is in the middle and it has like all of a sudden oxygen has other ones. How do you know how to like when to do that? That's my issue.
Like on this one,
Yeah.
because you're like, ugh.
Yes, because like chlorine,
Yeah.
like there's 2 on the top and then I'm like,
So if you look at this and you go through the steps, right? Like this is unpleasant, right? This is like a worst case scenario here, right? Because chlorine just needs 1 and you're like, But all of these oxygens only have 6. So when you look for single bonds, you're like, well, again, all of these things are just kind of hanging out in space, right? And so these electrons, they're not just sitting there like, nope, I'm good, I just live right here. Like they're moving constantly. And so if we're like sharing electrons with things and we're close enough, they're gonna end up sharing even though they really technically belong to the chlorine because it's all shared. So those, it's like when you have a 3-year-old and a 2-year-old. And like the 3-year-old has toys and they're 3-year-old toys. Like, you know, like ages 3 and up on the box. That
Do you follow
2-year-old,
that?
That's relevant. Keep
ask me later when the recording's off.
Oh my god.
Like the 2-year-old is gonna get a hold of the 3-year-old's toys. Because even though the 3-year-old has it, the 2-year-old wants it. The oxygen wants those extra electrons. It needs 8. So a good way to do that would be to look at them and be like, okay, these all have 6. This has 7. Where are bonds gonna form? Well, obviously this one guy needs to bond with something, right? So this is like the no-brainer bond right there.
Oh, it's a 7.
So now 7 is up to 8. This is up to 8. Now you're stuck. 2.
Wait,
Thank
how's
you.
that?
You're on it,
That's
Andrew.
easy.
That's 7. Okay. So now we're looking at these guys and we're like, this has 6. That one's fine. This has 6. This has 7. Okay? What are you
So
gonna
you
do?
just move some of the ones that are over there to the oxygen and then just bond it like that.
These guys are gonna end up getting shared
Okay,
because
so you just
they're
move
close
one of them
enough.
over to the oxygen and bond it. Okay, that's
Yeah.
where I was confused. Like.
So
where
that
you-
just kind of and this kind of
Okay. All right. Now.
So that should be your last resort if like you really can't see how it works out.
All right. Sweet,
Okay.
thank you.
Extra electron swoops in. These all have 8.
How,
It's like I'm gonna save the day for this 7
how did it go from 6 to 8?
because every double bond is 2 electrons.
Double bond, that's a single bond.
Single bond.
Oh,
You're on it, Andrew. Yeah. Okay. So single bond, 2 electrons. So 2, 4, 6, 8. Okay. Cool. All right. We have someone dying in the back. Please don't die. Thank you. Oh, okay. All right. So HCl, hydrochloric acid. This one's like your easiest answer ever, right? Hydrogen wants 2, chlorine wants 7, or wants 8. It has 7. This guy has 1. If you bond these guys, hydrogen now has 2 because it's sharing that one and its own. Chlorine now has 8 because it's sharing 2, 4, 6, sharing those 2. 8. Okay. So that's like your easy way to know one bond is 2 electrons. If you have a double bond, it's 4 electrons that are being shared. So that would be like CO. Yeah, we can do that. So CO is probably going to share 4 electrons. And then you have your triple bond, which is cyanide, is our good example. That's sharing 6 electrons. Okay. Lewis dot structures, know them, love them, put them under your pillow at night. You'll enjoy it. Okay, chapter 5 was evil. The biggest thing that I can say about chapter 5 is you have to know your stuff. And what stuff do I want you to know? It is as follows. If you look at your notes, it's going to like overwhelm you, much like God's overwhelming. I wouldn't go reckless though. I feel like that's where I draw the line. His love though, quite overwhelming. Yeah.
What makes them diatonic again? Like, why are they?
Because they're so reactive that they react with themselves.
So they just like feel here. Okay.
well, I thought it was because like.
So like you have oxygen and oxygen. And it's like, I can't get 8. So they share 4.
Oh, okay.
Right? And so like they're so reactive that they're gonna react with themselves. And they naturally appear. All the halogens, they want that extra electron. It's bad news. So that's that. All right, chapter 5. You should know at least, if I give you a periodic table, you should be able to tell me the following families or groups of elements. So, alkali, alkaline earth, should know transition metals, should know post-transition,
Do we have to know what's in them?
you should know the metalloids, you should know the non-metals, you should know the halogens.
What's something look like on the test? Like,
I'm gonna get there. Noble gases, and then the lanthanides, actinides. So I should be able to give you a periodic table, and then you select where each of these live. Okay, and like fill in the blanks. I should be able to say, hey, what is one fun fact about the halogens? What is one fun fact about the halogens? Are you volunteer?
Needs.
You're asking a follow-up question?
Yes, are we gonna have to know like locations tomorrow? Okay.
Wait, do we need to know what's in them?
Do we need to know what's in them?
Yeah,
Like
like-
which specific elements?
Yeah.
I haven't given you that quiz yet, so I'm likely to not test you on it.
you just wanna know which, like, section of the periodic table. thing.
Yeah, so like you should be able to be like, You should be able to be like alkali, alkaline earth, transition, post-transition, the metalloids, the non-metals. Don't ask me to tell you what any of these things are, by the way, once I've written them. Halogens,
God bless my
And
friend
noble
Michael
gas.
Raymond Vitale.
and then your lanthanides, actinides. Okay, so you should have like a general feel. If I give you a blank periodic table, like where are these? There's somewhere over
It
there.
needs to be like the exact, like know where like the post-transition ends and the metalloids
I mean-
start.
Yeah, that's just cruel. I'm not gonna do that.
Thank you.
Okay. You're just gonna give like a rough outline and then we draw lines in front of it, is what you're saying, okay, cool.
Pretty much.
Thank you so much.
Yeah. So like fun fact about the halogens, they need 1 electron, right? Fun fact about noble gases, they don't need 1 electron. They're happy. They don't like to form bonds with things. Fun fact about nonmetals, they covalently bond with things. They take a negative charge. Fun thing about metals, they like to give up charge. You guys will do fine. Study your old test. You'll live. Have a nice day.